Have you ever felt a connection with someone so deep that you just knew what they were thinking, even if they were miles away? It's a beautiful thought, right? Well, science has something even stranger, and it's called quantum entanglement. You might have heard of it. It's that spooky phenomenon where two tiny particles, like electrons, become linked in a special way, no matter how far apart they are. If you measure a property of one, you instantly know the same property of the other. It's like having two magic coins. If one lands heads up in London, you know the other one in Tokyo will be tails. Einstein famously called this spooky action at a distance because it seemed to defy everything we knew about the universe. For a long time, we thought this was just a quirky feature of the super-small subatomic world. A little secret the universe kept for its tiniest building blocks. But what if I told you that this spooky action is no longer just for the microscopic? What if we could entangle things we can actually see? Things that are, relatively speaking, huge. This isn't science fiction anymore. This is the frontier of modern physics. Recently, scientists have achieved something incredible. They've entangled objects on a macroscopic scale. We're talking about things billions of times larger than single atoms. In one groundbreaking experiment, researchers took two tiny aluminum drums, each about the width of a human hair. Now, that might sound small to us, but in the quantum world, they're absolute giants. They cooled these drums down to near absolute zero, just a fraction of a degree above the coldest possible temperature. To minimize all the jiggling and noise from heat, then, using a clever system of microwave circuits, they managed to link the vibrations of these two drums. They made them entangled when they gently poked one drum, causing it to vibrate in a specific way. The other drums, separated by a physical distance, instantly mirrored its quantum state. They were moving in a correlated, ghostly dance, connected by the invisible threads of entanglement. This is huge. It proves that the bizarre rules of quantum mechanics aren't confined to the realm of the unseen. They can and do apply to bigger things. So, what does this mean for us? Well, the possibilities are mind-boggling. Think about it. This could revolutionize computing. Quantum computers, which promise to solve problems impossible for today's supercomputers, rely on entanglement. Being able to entangle larger, more stable components could make building these powerful machines much easier. It could also lead to ultra-precise sensors. Imagine sensors that can detect faint gravitational waves from across the universe, or medical devices that can image biological processes at the molecular level with stunning clarity. We could even create unhackable communication networks, because any attempt to eavesdrop on an entangled signal would instantly break the connection and alert the users. This research does more than just open doors for new technology. It challenges our very understanding of reality. Where does the quantum world end and our classical, everyday world begin? Is there even a boundary? Or is everything, from the smallest particle to the largest galaxy, governed by these same spooky rules? We're starting to see that the universe is far more interconnected and mysterious than we ever imagined. The line between the big and the small is blurring, and we are right here witnessing it happen. But what we once thought was just a spooky curiosity is turning out to be a fundamental principle of our universe, operating on scales we are just beginning to explore. Thank you so much for joining me on this journey to the edge of physics. If you found this as fascinating as I do, please hit that like button, subscribe for more explorations into the wonders of science, and share your thoughts in the comments below. What do you think is the most exciting application of macroscopic entanglement? I'd love to hear your ideas. See you next time.